Hi, I'm Kuba, and today we'll speed up MLflow model serving with Rust. Last time, we've boosted the feature server and achieved very promising results with Rust. This time, we'll move closer to the models, speed up MLflow model serving, and decrease resource consumption. The MLflow is open source platform which covers end-to-end machine learning lifecycle, including tracking experiments, organizing code into reusable projects, models versioning, and finally, models deployment. With MLflow, we can easily serve versioned models. Moreover, it supports multiple ML frameworks and abstracts them with consistent REST API. Thanks to this, we can experiment with multiple models flavors without affecting existing integration. MLflow is written in Python and uses Python to serve real-time models. This simplifies the integration with ML frameworks which expose Python API. On the other hand, real-time model serving is a stage where prediction latency and resource consumption is critical. Additionally, serving robustness is required even for higher load. To check how the Rust implementation will perform, I have implemented the ML model server which can read MLflow models and expose the same REST API. For test purposes, I have implemented integration with LightGBM and Catboost models flavors. To perform benchmark, I have trained three very simple models: binary classifier for LightGBM and Catboost, and a multi-class classifier for LightGBM. I have used Vegeta attack to perform load test and measure P99 response time for a different number of requests per second. Additionally, I have measured the CPU and memory usage of the model serving container. All tests have been performed on my local machine. The performance tests show that Rust implementation is very promising. For all models, even for 1000 requests per second, the response time is low. CPU usage increases linearly as the traffic increases, and memory usage is constant. On the other hand, MLflow serving Python implementation performs much worse. For higher traffic, the response times are higher than 5 seconds, which exceeds timeout value. CPU usage quickly consumes available machine resources. The memory usage is stable for all cases. The Rust implementation is wrapped with the Python API and available in Yummy, as you can simply install and run it through the command line or using Python code. The whole implementation and benchmark code is available on GitHub. Currently, LightGBM and Catboost local models are supported. But if you are interested in other integrations, please let me know in comments or GitHub. That's all for today. Thanks for watching and please subscribe. Bye!